Well, we've been making a simulation, and the simulation is an event-driven simulation where the objects in the world are the objects in the computer, and the changes of state that are happening in the world in time are organized to be time in the computer. So that if something happens after something else in the world, then we have it happen after the corresponding events happen in the same order in the computer. That's where we have assignments, when we make that alignment. Well, right now I want to show you a way of organizing time, which is an agenda, or priority queue it's sometimes called. And I'm going to do a little bit of just understanding what are the things we need to be able to do to make agendas. And so what we're going to have are, right now I'm here, we're going to write down a bunch of primitive operations for manipulating agendas. Okay? But I'm not going to show you the code for them because they're all very simple, and you've got listings of all that anyway. So what do we have? We have things like make agenda, which produces a new agenda. We can ask, we get the current time of an agenda. Which gives me a number, a time. We can ask whether an agenda is empty. Empty agenda. And that produces either a true or a false. Okay. We can add an object to an agenda. Actually, what we add to an agenda is an operation, is an action to be done, and that takes a time, the action itself, and the agenda I want to add it to. And that inserts it in the appropriate place in the agenda. I can get the first item off an agenda, the first thing I have to do. Which is going to give me an action. And I can remove the first item from an agenda. That's what I have to be able to do with agendas. That is a big, complicated mess. From an agenda. Well, let's see how we can organize this thing as a data structure a bit. Well, an agenda is going to be some kind of list. And it's going to be a list that I'm going to have to be able to modify. So we're going to have to talk about modifying of lists. Because I'm going to add things to it, and delete things from it, and things like that. It's organized by time. It's probably good to keep it in sorted order. But sometimes there are lots of things that happen at the same time. Approximate same time. What I have to do is say group things by the time at which they're supposed to happen. So I'm going to make an agenda as a list of segments. Okay? And so I'm going to draw you a data structure for an agenda. A perfectly reasonable one. Here's an agenda. It's a thing that begins with a name. I'm going to do it right now out of list structure. It's got a header. There's a reason for the header. We're going to see the reason soon. Okay. And it will have a segment. It will be a list of segments. Supposing this agenda has two segments, okay, they're the successive cars of this list. Each segment is going to have a time. Say, for example, 10. This says that the things that happen in this segment are at time 10. And what I'm going to have in here is another data structure, which I'm not going to describe, which is a queue of things to do at time 10. It's a queue. And we'll talk about that in a second. But abstractly, the queue is just a list of things to do at a particular time, and I add things to a queue. This is a queue. There's a time. There's a segment. Now I may have another segment in this agenda. Supposing this is stuff that happens at time 30. It has, of course, another queue of things that are queued up to be done at time 30. Well, there are various things I have to be able to do to an agenda. Supposing I want to add to an agenda another thing to be done at time 10. Well, that's not very hard. I'm going to walk down here looking for the segment of time 10. It is possible that there is no segment of time 10. We'll cover that case in a second. But if I find a segment at time 10, then if I want to add another thing to be done at time 10, I just increase that queue. Just increase isn't such an obvious idea. But I increase the things to be done at that time. Now, supposing I want to add something to be done at time 20. There is no segment for time 20. I'm going to have to create a new segment. I want my time 20 segment to exist between time 10 and time 30. Well, that takes a little work. I'm going to have to do a cons. I'm going to have to make a new element of the agenda list of segments. I'm going to have to change. Here's change. I'm going to have to change the cdr of the agenda to point at a new cons of the new segment and the cdr of the cdr of the cdr of the agenda. The cdr. Okay? And this is going to have a new segment now of time 20 with its own queue, which now has one element in it. If I wanted to add something at the end, I'm going to have to replace the cdr of this list with something. I'm going to have to change that piece of data structure. So I'm going to need new primitives for doing this. But I'm just showing you why I need them. And finally, if I wanted to add a thing to be done at time 5, I'm going to have to change this one, because I'm going to have to add it in over here, which is why I planned ahead and had a header cell, which has a place. If I'm going to change things, I have to have places for the change. Okay? I have to have a place to make the change. If I remove things from the agenda, that's not so hard. Removing them from the beginning is pretty easy, which is the only case I have. I can go looking for the first segment. I see if it has a non-empty queue. If it has a non-empty queue, well, I'm going to delete one element from the queue, like that. If the queue ever becomes empty, then I have to delete the whole segment, and then this changes to point to here. Okay? So there's quite a complicated data structure manipulation going on, the details of which are not really very exciting. Now let's talk about queues. They're similar, because each of these agendas has a queue in it. What's a queue? Queue is going to have the following primitive operations. To make a queue, this gives me a new queue. I'm going to have to be able to insert into a queue a new item. I'm going to have to be able to delete from a queue the first item in the queue. And I want to be able to get the first thing in the queue. From some queue. I also have to be able to test whether a queue is empty. And when you invent things like this, I want you to be very careful to use the kinds of conventions I use for naming things. Notice that I'm careful to say these change something and that tests it. And presumably I did the same thing over here. Okay, and there should be an empty test over here. Okay, well, how would I make a queue? A queue wants to be something I can add to at the end of and pick up the thing at the beginning of. I should be able to delete from the beginning and add to the end. Well, I'm going to show you a very simple structure for that. We can make this out of conses as well. Here's a queue. It has a queue header, which contains two parts, a front pointer and a rear pointer. And here I have a queue with two items in it. The first item, I don't know, it's perhaps a 1. The second item, I don't know, let's give it a 2. The reason why I want two pointers in here, a front pointer and a rear pointer, is so I can add to the end without having to chase down from the beginning. So, for example, if I wanted to add one more item to this queue, if I want to add on another item to be worried about later, all I have to do is make a cons, which contains that item. Say it's 3. That's for inserting 3 into the queue. Okay. Then I have to change this pointer here, okay, to here, and I have to change this one to point to the new rear. If I wish to take the first element of the queue, the first item, I just go chasing down the front pointer till I find the first one and pick it up. If I wish to delete the first item from the queue, delete queue, all I do is move the front pointer along this way. The new front of the queue is now this. So queues are very simple too. So what you've seen now is that I need a certain number of new primitive operations. I'm going to give them some names, and then we're going to look into how they work and how they're used. We have set the car of some pair, or thing produced by consing, to a new value, and set the coulter of a pair to a new value. And then we're going to look into how they work. I needed setting car over here to delete the first element of a queue. This is the car, and I had to set it. I had to be able to set the coulter to be able to move the rear pointer or to be able to increment the queue here. All of the operations I did were made out of those that I just showed you on the last blackboard. Good. Well, I suppose it's time to take a little break then.